Now the topic before us is benefits of using a database management system over traditional file-based systems. First point is structure. DBMS is a software for managing the database. On the other hand, file system is a way of organizing and storing data on a computer's storage medium such as hard disk drive or SSD, that is solid state drive. In the case of file system, data is stored in files and folders. Next is centralized data storage. DBMS enables centralized storage of data in a structured manner so that the data can be easily retrieved. On the other hand, the traditional file system often leads to data duplication and scattered data files, making data management and retrieval complex. That is, in the case of traditional file system, it is difficult to manage data and retrieve data. Next is data consistency and integrity. DBMS enforces data integrity through constraints and validation rules. Constraints may be unique constraints, primary key constraint, foreign key constraint, referential integrity constraint, or some default constraints. DBMS ensures data remains consistent and accurate throughout the database. That is, all the persons or all the users who have access to the data view the same data. On the other hand, traditional file based system relies on manual checks and scattered data files, making data management and retrieval complex. Next point is concurrent data access. In the case of DBMS, multiple users can access and manipulate the data simultaneously without conflicts or data inconsistencies. Manipulation of data means updating the data, inserting data, or deleting data wherever necessary. In the case of traditional file system like those which is found on your computer, these systems, that is the file system, is not designed to handle situations where multiple users or processes can access the same file at the same time. Suppose you are having a computer, can 10 users can access the same data which is lying there on your computer? It is not possible in the case of traditional file system. Next is complexity and cost. In the case of DBMS, it is generally more complex and it is expensive to make use of DBMS because of the hardware or other software, because the DBMS is of advanced features. In the case of file system is simpler as compared to DBMS and it is more cost effective. That is, it is very less expensive as compared to DBMS. Next point is data sharing. DBMS supports data sharing among multiple users and applications. In the case of file system, data sharing may be challenging and prone to conflicts. Next is scalability. There may be chances that an organization is that the performance of the business of an organization is very rising very fast. That is, the products are selling like hotcakes and more users are approaching its website. That is, the organization may have to handle a large volume of data for large number of users. If the DBMS is being used by the organization, then the DBMS can handle large volumes of data efficiently. DBMS can scale to accommodate terabytes or petabytes of data. That is, in the case of DBMS, more servers or more computers can be added, or we can upgrade a single server or a single computer, such as we can upgrade CPU, RAM, or storage devices such as hard disk or SSD to handle the increased volume of data in case of DBMS. Whereas in case of file based system may face challenges in the case of scalability in managing large volume of data efficiently. As data grows, the performance may degrade. Next is backup. DBMS provides for regular automated backups at predetermined intervals, such as DBMS may backup at daily, hourly, or as has been specified for the DBMS system. DBMS ensures data integrity during the backup process even when the database is actively being used. It means that you are using database and at the same time backup is going on. There is no problem. Backup will be proper. But in the case of file system, there is problem. While system often lacks automated backups, users often need to perform manual backups. If a file is open or in use during the backup process, that is, file is open and at the same time backup is being performed in the case of file system, it may lead to incomplete or corrupted backups. That is, it may be possible that the file which is open will not be taken into consideration by the file system for backup purpose. Next point is point in time recovery. DBMS supports point in time recovery. It allows the user to restore a database to a specific moment or time in the past, that is, to a state before a critical event or data loss occurred. It means that suppose there is accidental deletion of data. This is a human error, and some important or all critical data is lost due to this accidental mishandling or human error. It may be also possible that there is some system failure or software bug is there or some hardware failure is there, and due to which some data corruption has taken place. So DBMS comes into role here. It plays an important role and provides for point in time recovery. That is, it restores the database to a specific moment or a specific time in the past. Now the question arises, what is the point in time? Whether suppose the database has suffered or data loss has occurred now. Now what is the point in time? Whether the point in time will be 1 second earlier to this time, that is, suppose Now it is 10. Now at 10 hours there is data loss. Whether the backup will be at 0.9.59, that is the restoration of data will take place up to 9.59 or 1 hour before, 1 day before, or some early, more days before. So the point in time recovery depends upon the configuration as well as the capabilities of the DBMS, that is up to which point the database has to be restored in the past. It next point, we take the case of file system. Traditional file based system does not generally offer point in time recovery capabilities, making it difficult to restore the data to a specific moment in the past. File system lacks transaction logs and other mechanisms which are necessary for efficiently and effectively implementing point in time recovery. Next is data querying. DBMS provides a query language such as structured query language for querying and manipulating data. The file system, on the other hand, does not have a standardized querying language, and data retrieval typically involves searching for specific files and parsing the content of files manually, which can be time consuming and error prone. That is, if we have to search any file, we will have to manually search the same. Now the word has been used, parsing the content. Parsing the content of files manually refers to the process of extracting meaningful information or data from files without the assistance of automated tools or software. That is, in the case of DBMS, if we give the command to the DBMS, the DBMS will provide us the desired information in the desired format, that too very quickly. But in the case of file system, if we want to search any data, we will have to search the same manually, and we will have to extract the data as we desire. That is, we will have to form the format of our own. The system will not do it. We will have to search the data which we require from various locations, from various files. Next point is data analysis. DBMS is better for data analysis because it has powerful tools like structured query language, indexing, and aggregation functions. DBMS organizes data efficiently. On the other hand, file system lacks such tools which help in data analysis. So it is very cumbersome or difficult to extract data, combine and analyze data from the files manually, because a lot of time will be required for all these doing all these tasks. Next is data security. DBMS provides advanced data security features such as user authentication. User authentication may be done by the way of such as username, then password, or two-way authentication. Access control, that is role-based access may be there, or time-based access may be granted. Encryption and data integrity constraints. Data integrity constraints means unique constraints, primary key constraint, foreign key constraint, referential integrity constraint, or default constraints, which we have discussed earlier. DBMS ensures secure data storage and protects data against unauthorized access. File systems do not have comprehensive built-in security features, so the file systems are more vulnerable to data breaches and unauthorized access making them less suitable for handling sensitive and critical data securely. Next, we take the example of DBMS. Let us consider a website. The website pertains to the online bookstore, and that bookstore sells books, tracks the customers' orders, and manages inventory. The website uses a DBMS. The example may be MySQL, PostgreSQL, and the website uses DBMS to store and manage data efficiently. The information in respect of books such as titles, authors, price is stored in a structured table, whereas in the another table the customer data like name, address, orders and other contact details and order history is there. On the other hand, there is a separate table in which inventory data including the number of books available is stored. So with a DBMS, the website can easily retrieve specific book details such as who is its author, what is its price, track customer orders, that is how many orders have been placed by a particular customer in a particular period, and manage inventory details, that is how much books or how much quantity is available of a particular book. So all these type of queries can be made from the DBMS very quickly, and we can take appropriate steps. Suppose if the books are in short quantity as has been revealed by the DBMS, we can quickly, the online store can quickly order for the supply of the more. Complex queries can be executed using structured query language to provide various reports and insights such as the most popular books or best selling authors. It means that DBMS helps us in a way that if we want to search that, or the online site wants to see which are those books which are in great demand, or which are the books which are not selling, all this type of information, or which customer is giving repeat orders, all this information can be provided to the user or the online store by the DBMS very quickly. Now we take the example of file system. Now let us consider a simple local bookstore with limited data management needs who uses a file system to store data. That local bookstore stores the information in individual text files on the computer, where each file contains details of one book, including its title, author, and price. Customer data is kept in separate text files with each one file per customer, and in each file the name of one customer, his name, order history is given. Now inventory information is stored in a single text file with basic list format in which the quantity of available books is given. While this simple file system approach is very good for a small bookstore, it lacks the efficiency, data integrity, and advanced querying capabilities of a DBMS. We have already learned that in the case of DBMS, we can quickly find out what books are in great demand, which customer is giving repeat orders, which book is not selling at all. In the case of DBMS, we can quickly find out the same. But in the case of file system, we will have to go through various files to arrive at certain conclusions. So in the case of file system, it can be more challenging to manage and analyze data as the bookstore grows and needs more sophisticated data handling, such as it means that if the volume of the data increases, the file system may not be proper to handle the large volume of data and the performance will decrease. In summary, DBMS provides efficient data management, whereas the file system is satisfactory for small scenarios, that is the small organizations. But file system is not suitable for storing and managing the large volume of data. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.